Yeah.
But we never talked about it in class. And then I have more stuff from the math Excel because I have a quiz.
Okay. So hey,
Honestly,
how did it go? Me kind of pre-teaching the unit circle, was that nice for you? Yeah. Was that helpful?
I mean, we never really learned it in class, but like when you were having me do with the angles on the plane or whatever, I like knew how to do that.
Okay, good. So which one are we going to do? Are we doing 14 through 19? Or are we doing 13 first?
13 first, probably.
Okay. So error analysis. On a test, a student wrote that the measure of an angle coterminal to a 50-degree angle is 310. Describe and correct his error. What am I, some sort of a sage? Am I going to be able to read the person's mind? This person was just an idiot. That's all there is to it. All right. Coterminal to a 50-degree angle. So what they did, let's see. What's 310? Where's 310 going to be?
My Jamboard isn't working. Hold on.
Can you see mine? Am I sharing my screen still?
Yes.
Okay.
310 would be.
So we're starting here, right?
Fourth quadrant.
And we're going 3. There's 270. So here's 310.
Yeah,
and that's
quadrant.
Oh, I see the error. I see it.
Classic mistake.
Classic. Do you see how they did 310? This is 310 degrees, so that means this is 50 degrees.
Yeah.
If this whole thing was 310 right here. 310. They got the coterminal one for the negative 50-degree angle.
Yeah.
Yeah. So say that however you want. Describe that however you want. And what is the correction to the error? What should the answer be?
Could you add 50 to 360?
Yeah, exactly. So I would describe what they did is they subtracted 50 from 360. They should have added it.
Yeah.
The correct answer is 410.
Okay.
Got it?
Yes.
All right, next, find a positive and negative coterminal angle for the given angle. Okay. So I'll do the first one, you do the second one. Deal? 65 is right about here. So a negative coterminal angle, I shall use black for the negative one, is going to be like this. So it's 360 minus 65, and it's the negative version of that. Or I should say it's negative 360 plus 65 to be correct. And your answer would be negative 295. Negative 295 degrees. There's my negative one. And what would the positive one be? I keep going in this direction, right? Which means I add. Yep, I add 65 to 360. Got it? Whoops, I wrote 36. 65. Which is what? 425?
Yeah.
Good job. All right, you try number 5. Show me your awesomeness. Show me your skills.
We're gonna load into the Jamboard. Okay. I have a pencil. So for this, draw the lines. Oops. Negative 30 would be that's negative 180, so it'd be like here, right?
Good. And what's that reference angle? Oh, there's that word. This is your reference angle.
Oh, reference angle, that would be 50, -50.
Good job. No, not -50. 50.
Just
They're
50?
always positive. Yep, they're always positive.
Oh,
Reference
oh,
angles are always positive angles.
okay.
Now they didn't ask that, but it helps to write that in.
Okay.
Do you know why it helps to write that in?
No.
Because now when you're finding the positive angle, all you have to do is what?
I don't know.
Think
Oh, add it?
180. Think 180 plus 50. You see what I'm saying?
Not really. Oh,
If
yeah.
if this is that angle, if I'm thinking instead of going this way, I'm going to go this way. What am I missing here? I'm missing. There's 180 plus another 50. If I have that reference angle there, it just makes it easier to visualize that, in my
Oh,
opinion.
okay.
You don't
No.
have to do it
Yeah.
that way. You can just add 360 to 180, but I'm sorry.
Yeah.
No, I'm sorry. Subtract 130 from 360. You could do it that way too. But it's good to see it and understand it visually, I think, for people. Anyway, so how about the negative one?
-1 would be -490.
Good job. So I think you figured out the little trick, right? All you're really doing is adding or subtracting 360. So
Yeah.
the pictures aren't super necessary, but again, I wanted you to see it. So if you add 360 to it, you're going to get 230, and that's a positive. If you subtract 360 from it, you're going to still be negative. So that's -490.
Okay.
And if this one didn't happen to be at the positive yet, like in this instance, in 19, when I try to add 360 to it, I'm still going to be negative. It's still going to be -40. So I have to do it again. Add another 360 to it, and you get positive 320.
Okay.
Does that make sense?
Yeah.
So there's your two negative. There's one of your negative ones, and there's your positive one. You just saved some time.
Oh. Okay.
Okay. Or you
Mm-hmm.
could have subtracted 360 and it would have been -760, but that's like super far negative, which is
Yeah.
fine. They didn't care. They didn't ask in particular.
Okay. So
Do you
then
think you can
for
get the rest of those
16.
yourself?
Yeah, let me do 16. Oops, I don't know why this is red. And then it would be 250 minus 3. 250 minus 360. Okay. Yeah, I understand how to do that now. So
All right. So number 20, shall I help you with 20?
yes.
A periodic function has an amplitude of 14, so that's my A, and a minimum value of -3. Ah, what is the maximum value? Well, the minimum value means that it's down here. The minimum value means it's right here. Here's -3. There's my minimum value somewhere. I don't know where it is on the XY. That doesn't matter.
Mm-hmm.
What's the maximum value? Well, what does it mean to be an amplitude?
It's how many away from the midline, right?
That's right. So the midline is going to be 14 away from that. So
And
what's
then the
my midline
maximum,
going to be?
um,
What's 14
11.
away from -3?
11.
11. Good. You probably said that. I just didn't hear it. It's
Yeah, I did.
11. That's your midline. Y equals
Mm-hmm.
11. I'll answer that question first. And then what's your maximum value? How do I get to my maximum?
You'd add 14 to that, so that would be.
Let's go. Good job.
What would that be, like 25 or something?
Something like that. I don't know. Who knows? There's really no way to know.
So true.
Good job. That was easy.
Yeah.
More? Is that all you got?
Hold on, I can find more. I have to go on Math Excel now. Math Excel. Scan kit. Wait, no, what the heck? What is this doing? Okay. One moment. Hey, Mr. Dwyer.
Yeah.
Did you know it's Tuesday?
Yes.
But not like Tuesday. It's
I do. I know
Tuesday.
exactly what you mean. Hey, do you know that the page we're on is 2 of 2?
Oh my
On
gosh.
2/2/22, a Tuesday.
That's so crazy. Wait a minute.
What
I
are
have
the
no
chances?
Math Excels that I need to do.
And do you know that it's 6:22? It was 6:22 2 minutes ago.
That's crazy. Did you know at 2:22 I took a picture on 2/22/22?
Did you? That's awesome.
Yeah,
That was very smart of you.
I know.
But I hope
Okay,
you
so I
woke
have
up
no
at
Math
2
Excel.
in the morning, because otherwise it was really 14:22.
Yeah. But then at 10:22, it's going to be 22:22 military time. So,
Oh, that's even better.
yeah.
I like that even better. Take a picture of that.
Yeah, I will. I have no Math Excel, so now I have nothing to do. So,
Oh, that's awesome. I love when that happens, because then we can preview stuff. What
yes.
shall we preview?
The next Math Excel is called Radian measure.
Radians? Those
You
are
taught
so
me that,
easy.
didn't you? Didn't you
I
teach me
did.
radians?
So remember,
So
pi
many people have taught
radians,
me things.
pi radians equals 180 degrees. Those are two different ways to measure an angle. Okay. And if you remember the unit circle that I previewed for you,
Yes.
here's 180, right? Which is also pi, which is nice because that helps you understand how you can convert from degrees to radians. And that's the next thing that they're going to talk about probably. So they're going to have you do something like this. What is 60 degrees in terms of radians?
Yes.
So what you do is you use a conversion factor. And your conversion factor is either pi radians over 180 degrees or 180 degrees over pi radians. It's one of those two. And the way you know which one to use is whatever you're given, that should be on the bottom.
Oh.
So they can cancel out. So there's my pi radians over 180 degrees. Hey, guess what's going to cancel out? Remember how when you have a degree on the top and the bottom, they cancel out? The same is true with radians. I'm sorry, with degrees. Units of measure. So this equals 60 pi over 180, and there's 3 60s in 180. So that's just pi over 3 radians.
Okay.
Got it?
I always
so you try one.
I always get those on my SAT tests, my practice SAT tests. And my math tutor taught it, or my SAT tutor taught it to me. Now you're teaching it to me. I've learned this like 3 times and I still can't remember it.
So here we go. 30 degrees. How many radians is that? Go.
Okay.
Show me what you got.
Gotta do pi radian 180 degrees. The degrees cancel. Pi over Would it be 6?
You got it.
I just guessed because this and this.
You're so smart.
Okay.
Don't ever do that again. Okay.
Radian.
Good. Let me teach you a little trick about reducing. 30 over
Okay.
180.
Mhm.
Well, the 10s cancel, right?
Oh, so then it would be 6 because of this.
So it's 3 over 18, and 18 is really 3 times 6. So those cancel, so it's just 1 over 6.
Oh, okay.
That's how you should think about reducing fractions. Don't use a calculator. Break down a number into its primes. And I could have actually broken this more, right? 2 and 3. But I knew that it had 1 3 in it. 18 had a 3 in it, so that was going to cancel with that 3. And
Yeah.
and there's a 1 left on the top, not 0. There's always a 1 left.
Okay.
If everything else cancels out, you can't just get rid of it.
Yeah.
Okay. So let me try another one for you. Let's go the opposite direction. I'll do the first, you do the next. What is 5 pi over 3 radians in degrees? So what was the trick I just taught you? What do you put at the bottom?
Radian.
I put radians.
Pi radian.
Which means I put degrees at the top. There you go. Notice what happens. The pi's cancel. Let's go. And now I'm going to show you another trick here. Instead of multiplying 5 times 180, let's break 180 into 18 and 10, and 18 is 3 and 6 and 10, right? Why would I want to do that? Because I have a 3 on the bottom. And what's going to happen?
The 3 cancels.
Cha-ching. And now I can multiply them back out. Let's be smart. 5 times 6 is 30. 30 times 10 is 300 degrees. Done. You try this one.
That's not too bad.
No, it's not too bad. How about this one? How about 5 pi over 4 radians?
Okay.
Show me how many degrees that is. I'm going to let this new student in. Give me a sec.
Okay. Pi cancels. Then you have 5 times, what times 4 makes 180? 45?
You got it. Hi, Sophia.
Oh, let's go.
I'm working with someone else here. I figured I'd let you in and you can see how it works here. Sarah's just about ready to finish. Sophia, what class do you take?
I'm in honors pre-calc.
Okay, sounds good. So she's just converting radians to degrees and vice versa, having a good old time. Sarah, how are we doing this?
Oh, wait, never mind. I figured out what I did. I confused myself, but now I unconfused myself.
Good. Now you could have just gone like 2, take half of it, right?
Oh.
You could have done that and then take half of it again. That's even easier.
That is easier.
So 45 times 5. Here, let me show you a shortcut for that. 5 times 45 is like 5 times 40 plus 5. So it's like 5 times 40, which you can do in your head, plus 5 times 5, which you can do in your head. 5 times 40 is 200. 5 times 5 is 25. So it's 225. No need for a calculator. All right.
Let's go. Okay.
All right, Sarah. Good job.
Cool. I'll see you on Thursday.
If you want to come back at 7, go ahead.